This process is very close to yogurt. The only difference is instead of growing on sugar, we've selected organisms that grow on methanol.
Welcome to the Project Report. Join your host, Elyse Dzenick, as she sits with researchers and highly qualified personnel working on FES-funded research. Explore what they're working on, why it matters, and what's to come.
I'm joined by Dr. David Bressler, Chief Strategy Officer at the University of Alberta and Professor at the university's Faculty of Agricultural Life and Environmental Sciences. He also runs the Bressler Lab on campus, which focuses on biorefining, conversions, and fermentation, especially in the agricultural sector. Recently, David was interviewed by 2 news channels about his research, and today he's talking to us about his work. So welcome.
Well, thanks for having me. This is a wonderful opportunity.
You've partnered with an Alberta-based startup called Dzenick to develop a protein that's derived from fermented coal. Is that correct?
More or less, yeah. It starts with coal. They gasify it, recover the hydrogen as an energy resource for the province, and a small amount of hydrogen is redirected to make methanol, which we then ferment to make the protein product. Our lab is a conversions lab, so we study how to take the resources that are present in a place like Alberta that has agriculture, forestry, and non-renewable resources, and we study the chemistries to convert, feedstock A into product B. And so a lot of it is shuffling oils and fats into fuels and jet fuel, or fermenting sugars or methanol to make other products of value. So the products could be chemistry, chemicals, pharmaceuticals, or material applications. So it's a little bit of all of the above. The core of engineering, if you think about it, is looking at mass balances, energy balances, and then when you go into the bioeconomy, which is where we work, everything is around a circular future economy. And so we talk about circular, which means things are reduce, reuse, recycle, and you kind of are looking at the energy imbalances. So whenever you look at a process from the beginning to the end, you want to minimize the carbon footprint. So you want to make sure where you can, you're capturing carbon, where you can save energy, you want to do that. And then what we do in our lab, the simplest way I like to think about it is we study ways to use either enzymes or microbes or chemistry or even high temperature chemistries to convert products along the pathway. And we're really just creating options. And then the industry will look at which options make economic and sustainability sense. And they will scale them up and commercialize, which we've seen a couple times.
Yeah, in terms of optimization and just making the process better overall, you're just making everything a little bit more sustainable each step of the process.
Well, that's the goal. But when you say you, it's not me. Like, it's an army of grad students and postdocs and collaborators and so some of our collaborators are true chemical engineers. Some of them are in sciences, but some of them are social sciences, studying like the economics and the supply and markets around how the policies may affect these pathways. And so one of the things that future energy systems allow us to do is work across that ecosystem with complex partnerships, which means you have more market or industry ready solutions when they're kind of evolving out of our ecosystem, if that makes sense.
Yeah, that does make sense. How did you end up working in this, niche industry?
Well, I took a circuitous route that went from a long-winded route around a lot of different areas, but my degrees are from science. My postdocs were actually in chemical engineering with an office at Syncrude upgrading. And then from there, 25 years ago, I took a position in the agriculture and forestry-based faculty to look at biomass conversion into fuels, chemicals, and materials. We started with an organism that ferments methanol to create the single cell protein. But we start with like Petri plates, and then we go to shake flasks, which may have a couple hundred mils, and we optimize the media because we want to be very efficient on what we give it and maximize the growth rate. And this organism is like a little inferno because it needs a lot of oxygen and it generates a lot of heat while it's growing. So a lot of it is designing the system to accommodate for that. But the way the research is done is we move to 5-liter fermenters, convert it to a continuous process so media is being pumped out, in and out. And so in the reactor, there's like 2 liters of culture growing, and every hour it's turning over 400 mils. So 1/5 of the volume is coming out as a product every hour. And so that requires an army of people. So in the lab, there's like 3 postdocs, several grad students, and what they work on in the project is, they're all optimizing various aspects. So whether it's the fermentation or the recovery or the downstream product, they're working on all the solutions for the industry partner. This process is very close to yogurt. The only difference is instead of growing on sugar, we've selected organisms that grow on methanol. And so with yogurt, they grow on sugar, the two bacteria, there's actually two types of bacteria yogurt that are growing. They break down, the products that are in their feedstock, or the milk, really the sugars, and they convert it into the bacteria, which is the pasty material of the yogurt that we eat. So we're eating yogurt for protein and the extra cellular ingredients that they're making. And methanol is toxic at low percentages. So our art form is about finding ways to grow the culture continuously and pouring the methanol in at rates that are maybe 4 times higher than the toxic level. But we're doing it in a choreographed way so the cells are using it as fast as we're putting it in, so it doesn't accumulate in the reactor. Nice. So it's a little more complicated because of that balancing, but at the end of the day, the cells are using the methanol as carbon and energy, very much the same way the yogurt bacteria use the sugar. And in the end, you end up with protein, and which, in our case, the organism was selected to give a very high value profile of amino acids. Whereas yogurt, it's the traditional flavor that we're looking for. In this case, the strain was developed to have just the right amino acid composition to be a high value feed additive.
Very cool. So instead of a lot of probiotics, then you end up with a lot of protein.
A lot of protein, yeah. A version of this process was done in the 70s and 80s in the UK, and they made a lot of this protein for feed in another era with different technology. And so what we're doing is we're resurrecting in some ways and modernizing with 40 years of advancement in controls and fermentation technology to do it in a much more, almost better balanced, more sustainable way. But there's nothing stopping that protein from being entering into the food marketplace. And the size of the fermenters that were used in the 70s and 80s are like huge volumes. So they made more protein than all other alternative protein combined since. And it was all in animal feed in the 70s and 80s. So we've resurrected kind of an older pathway, but modernized it in a lot of ways. And what makes this project really special in my mind is we meet with the industry partners every week or 2 weeks for an hour. And so the postdocs and grad students are presenting what happened over the last week. And the industry has brought on 3 senior consultants from Europe and at one point 1 from Israel that were, advising weekly with these postdocs. Wow. And so our trainees and the postdocs, what they're learning is how to do research that's very fundamental and with all the high standards, but they're learning how to answer questions for the industry. They're now anticipating what's going to happen next week. And so they're designing their experiments in a way that their outcomes are going to be really meaningful for that partner. And they're at the same time building future job pathways, right? Because they're building that relationship with the industry clients.
Yeah, that's fantastic that you mentioned the collaborative process is not only resulting in a better sustainable future for everyone, but also is giving the students an opportunity to build their own futures and build their pathways and have more of a hands-on training, not only in the research in the lab, but also communicating what they're learning and incorporating that back into the research.
Well, and for me, I'm in my career. I know what I'm doing for my life. I have my relationships. So for me, one of the most rewarding things is seeing all the trainees, seeing that next step in their job and where they're going. And I'd like to think our lab is a little bit unique, even on this campus, of giving them that direct relationships with industry, so that they're actually learning their communication skills. They're learning how to be very concise and say things in the way the industry and the right language. For them to take it, run with it. And now in the last month or 2, they're even getting the experience of talking to the press and learning how to communicate for the general public a little bit more than they would have in other pathways, I think. On the single cell protein, we work with Civictus. That's the Alberta registered company that's scaling this up globally. What gets exciting is the Gates Foundation. A lot of the press lately is about they've stepped in to fund the actual scale up, the animal trials, working with my collaborator Ruud Zylstra in the Faculty of Ales as well, who has 20 years experience blending feed ingredients. And really the goal there is to develop pathways that could help develop protein for the world. So Africa, India, everywhere with this technology from methanol. And on the other side, working with forged hydrocarbons, which is the U of A spin-out from our lab and our work on the jet fuel. They've been able to take that and get investments from Shell and Chevron and Lockheed Martin, and they're scaling commercial facilities right now in a couple of locations in Canada.
Yeah, that's really interesting. And to see it go from right here at the university to then with across Canada and now even globally is fantastic.
Well, in each of them, we talk about academics being in their lab doing their thing, and it's like we license it and the industry does it. But the reality is more complicated than that. We have collaborations within the university, we have funding support from the province, so Alberta Innovates, and things like the research-driven agricultural research, so ARDAR has funded a lot of the type of work we do. Future Energy Systems and the federal government and NSERC. So they all kind of come together to fund us. But then what happens is we work with our regional partners like the National Research Council and Natural Resources Canada, who have piloting facilities. And so like in the JET project, it was a very complex $7 million ecosystem with all of those players helping to scale and optimize the technology. So it takes a village to move the really impactful technologies forward. It's not just one academic in their lab. For 5 years, I was associate deans at the college and in the faculty. I think the one thing that I've learned over that time, especially in the last 5 years, is there's a lot of discussions of academics being ivory towers and but I think at the end of the day, every single academic I've ever met on this campus cares about impact. And the impact is our impact on our communities and our society. And whether it's a social scientist or artist or a chemist, people want to see impact from their careers. So I think it's been bad labeling that academics want to sit in their ivory tower, and maybe they don't all have the right communication skills to express what their visions and what the outcome will be. And we can do better at communicating, but I haven't yet met an academic that didn't care about the impact of their work. And that impact is to society and into our communities and into the earth and the environment. It's just sometimes we don't eloquently say it the best ways, but I think we're repositioning and remobilizing to make it clear what our impacts are on our community.